Hello guys, welcome back to Manala's Arc. Oops, what is that? It's been a while since I posted a video here on the group, and thank you for being patient with me. So let's get to it. My video today is for grade 11s about Trig graphs. I'm basically answering a question from a previous paper here, and yeah, let's get to it. I don't have much to say on an intro. I must work on my intros. The question that I want us to work on is coming from a grade 11 paper written in November last year, 2023, and it's a Gauteng paper, right? So this is question 6. This was their trig function question here, and I couldn't paste the whole page here, so I posted half of the page here, which depicts the diagram, and then the questions are here. So I'll keep on flipping around the diagram and the questions here, so please bear with me there. And I want to stress with you now that educational content doesn't get old, guys. It never gets old. So what I'll need from you, so what I'll need you to understand is that if ever I had a video last year about something, you can go there and watch the video, especially if it speaks to the basics that you are lacking for the current year. And this video here that I'm posting now, you are definitely going to need it by term 4, right? Okay. Now, let's skip all that. Let's get to answering the question. So this question is 14 marks, and I want to question you guys that a 14 marks question, it means you're supposed to answer this in 14 minutes or less. I prefer less. I'd rather do this in 11 minutes or 12 minutes if you're slow. Never take 14 minutes on a 14 marks question, right? So that's how things are. Why am I saying that? Because of this question here, it's worth 1 mark. I don't expect you to spend 60 seconds to answer this question, and I'll show you how, right? So now let's get to it. Let's keep on saying let's get to it, but I never get to it. So 6.1, to answer the first question. The first question says, write down the period for the graph of G. So now the graph of G is this one here. You can see the graph of G, right? So the graph of G, if I ask you to give me the period there, basically, I want you to understand that a period refers to the amount of degrees it takes you to get a full wave. So this graph, its wave starts here, it goes and ends here. How many degrees did it take us there? It took us 180 degrees. Now, as for me, because I write as I'm explaining, it will definitely take me more time than you would, right? Okay, so 180 degrees here, 1 mark, there it goes. I hope it was 1 mark. Yes, it was. Now, the next question says, determine the range for g of x. So we have to go to g of x, and for g of x, you choose a pen there. Here's what we have. The range for g of x. Now, we are talking about the point, the y values that this graph can cover. So the smallest y value the graph of g can cover, it's this one. The highest value the graph of g can cover, it's this one. So putting that as a range, what are we going to have? We're going to say now our range, y is an element of, it starts from where? From negative, what? Negative half. Negative half. It goes up until what? Up until positive half. And it touches positive half, so square brackets there, right? The next question. So how many marks is this? 2 marks. Trust me, this is what 2 marks. This writing, it's what will get you 2 marks, right? So now 6.3. 6.3 now it's divided into several questions, right? So let me put 6.3.1 here. And what is the first one? It says, tell us where f of x is bigger than 0. Now, when you read something like that, I need you to convert this from the complex mathematics lingo into a more simpler sentence. I need you to put it in layman's terms. Like, I need you to explain this to a beginner of trig functions. When they say f of x bigger than 0, they are telling you that give us a situation, the x values, whereby the graph of f, its y values, the y values for the graph of f is bigger than 0. And what does bigger than 0 mean? It means positive, right? Equals to 0 or bigger than 0. So we want the y values for this graph where they are either 0 or positive. Either it's on the x-intercept or it's above the x-intercept. That's what we want from this graph. Let's go there. Where the graph is on the x-intercept or above the x-intercept. This is the part, x or above. So let's determine the x values there. This happens when x is found between 45 degrees and what, 90 degrees. Now, does it include 45 degrees? Yes, because on 45 degrees we have the x-intercept. Does it include 90 degrees? No, because there you have your asymptote. This graph doesn't touch the asymptote. Another way you can write this thing for me is to say x is an element of, you put a square bracket because it includes the 45 degrees running up until what? Running up until 90 degrees. Does it include 90? No, so we put a parenthesis or a curve bracket there, right? Now, the next part, 6.3.2. It says here, tell us where the y values for f and multiplied with the y values for g, they'll give us something greater than 0. What does it mean? Y value of f and the y value of g will give us a positive answer. When does that ever happen? It happens when this and this are both positive, or it happens when this and this are both negative. That's the only case where you'll get a positive answer, right? We good. So what does it mean? In layman's terms, it means give us where both these graphs are above the x-axis or where both these graphs are below the x-axis. So let's do that. That happens when a situation whereby both these graphs are above the x-axis here. From here up and no, that's not the case. I almost lied there. Where are they all above the x-axis? Here they are all below up until there, which works for us, but I'll get to that. Here one of them is above, doesn't work for us. Here one of them is above, doesn't work for us. Here one of them is above, so it doesn't work for us. So, but yeah, but here and there they're all below. So there's no situation whereby all of them are above the x-axis as far as I'm looking at this diagram. Now let's look at the situation whereby all of them are below. So from here up until there, they're all below for some reason, like there. They're all below the x-axis. So we are saying this happens there. It also happens when here, right here, at this point here, they're all below the x-axis. You see that? So that's where it happens. Otherwise, in other situations, one of the graphs is above the x-axis and one of the graphs is below the x-axis. Now let's put this pinkish thing in writing, right? We are going to have, let me put that. We are going to say now, this thing happens between the following x values. And remember, it doesn't include, because from our question, it had no inclusive thing. So it happens from 90 degrees. Does it include 90 degrees? No, because one of the graphs there, it's at an asymptote. It happens from 90 degrees up until what? Up until 45 degrees, right? Where else does it happen? It also happens from, no, that is negative 90 degrees, from negative 90 degrees to positive to negative 45 degrees. This is the first part here. I hope you can see it. It's from here to there, from negative 90 to positive to negative 45. That's when all of them are negative, right? Elsewhere where it happens, it is here from positive 90 to positive 135. So let me write that. 90 to 135. Right there. So if it's 2 marks, he had a 2 marks there. Right? That's all that. All that. The next question, it says, give us the 6.3.3. Now that's a good one. Guys, so please bear with me if I ever make any mistakes here. I'm solving this thing for the, I don't want to say for the first time. I probably have done this before, but today I'm looking at this thing the first time here and I'm attempting this thing real time. Right? Okay. So this is a good one. They're saying, tell us a situation whereby this plus that is equals to 2. And they're saying, use the graphs to determine graphically. So which means we actually have to use the graph to do that. However, we don't have this equation on the graph and we don't have this equation on the graph. So let me copy this and go write it there. We have 2 tangent x and positive 2x that is equals to 2. Let me write it here. This will be interesting. 6.3.3. How many marks? 3 marks. Okay. It says 2 tan x plus cos 2x is equals to 2. Cos 2x is equals to 2. Now, if we have to use the graph here, we want to first see if we can derive these things to imitate these equations that we see here. So I see that I have 2 tan x, but here I just have tan x minus 1, okay? And here I see I have cos 2x, but for the cosine I have negative half cosine 2x, right? So let's see. I can try to manipulate this thing so that it looks like this equations here. And how do I do that? I can take this 2, send it to this side. I can take this cosine, send it to the other side, and see if it works out. So I have 2 tan x. When I send the 2 to this side, it becomes negative 2. This is equals to. When I send the cosine to the other side, it becomes cosine 2x. Right? Now, this looks beautiful now because it does show now that it will work out. I hope you can see it. So if I have to make the coefficient of the tangent of x to be 1, I have to divide this part by 2. Right? If I divide one component in an equation by 2, everything else now has to be divided by 2. Right? This leads me to what now? This leads me to have this and this cancel out. I'm left with the tangent of x minus here this one and this one cancel out. I'm left with 1 is equals to here. I send the cosine to the other side without a negative, so the cosine is negative here. Told you guys I'll make mistakes, but the cosine is negative. So which means now I have negative half cosine 2x. Now, you see what happened there? What happened now is that these equations have transformed. We've transformed them to be what we actually have on the question. Negative half cos 2x, it's actually the graph of g. We see that. And then this part here, tangent x minus 1, that is the graph of the f here. So basically with this question, in a tricky way, they were asking you, where is the graph of f equals to the graph of g? Give us the x value where the graph of f is equals to the graph of g. That was a smart way for them to ask that. So that happens when just at 45 degrees there. When x is 45 degrees, the graphs are equal. That's the only point where they meet. We good? Now to the next part. I'm running out of time now. I'm 13 minutes into the question and I have to finish this question as soon as possible. I was hoping I'll take less than 14 minutes, but obviously that's impossible. 6.4, it says, okay, let me try 6.4 here. It says, if this, describe the vertical translation. Let me put my laptop on silent, please. Because I'll keep on getting notifications. Right there. So, it says now, if h of x is equals to that, in this situation here, describe the vertical translation from h from f, right? So let me write this equation on the other side there. So this question is worth 2 marks, and here I've written it here. Describe the vertical translation here. So what this demands from us, it's like the previous question. The examiner is becoming tricky here. So let's see how we can solve that. So this, I see that I can actually try to break this down into the sine of x over the cosine of x plus the cosine of x over the cosine of x, right? So now my h of x will be equals to, this is a trig identity. Do we call them identities? Yeah, I think we call them identities. That sine of x over the cosine of x is equals to the tangent of x. We did this in general trig last time. So plus this and this one gives us what? Positive 1. Now, if we were to talk about the transition from the graph of f into the graph of h, what this becomes now, it demands from us to question the difference between this graph and this graph, that what happened between the two graphs. So basically here, this was negative 1, but now here it's positive 1. It means this graph here, it was moved. And how many times was it moved for it to move from -1 to +1? It means it was moved 2 times. Because when you move it the first time upwards, it's going to get to 0. When you move it again the second time, it will get to 1. So this graph was moved 2 times upwards. So now our conclusion here is that the graph was moved, I know you can see that, 2 units upwards. I'm trying to be fast here because I'm even running out of time. You see that? That's 6.4. That's how you do it. That's 2 marks. That's basically 2 marks. Probably they'll put a mark there and a mark for the conclusion. I don't know, but just write every step. All right. It's best to write all the steps. The next question says, determine the maximum value of p of x if p of x is 4 multiplied by the g of x. Now, let me write that question. Now, here is the question here for 2 marks. It's 2 marks, right? So what they were asking from us here is that there's a new graph now. And this graph, it's like the graph of p of x. And how was that graph formed? It was formed from the graph of g, but we have to multiply the graph of g with 4, right? What was the graph of g? The graph of g was half the cosine of 2x, right? So which means now we have to multiply this part with that part here. Right, so now which means our p of x becomes what? It becomes 4 times -half, it's -2, and the cosine of 2x. So now this is the graph that we have. Right? So now the next part that I'm going to throw here, you don't need to include this part, but I'm going to put it there, and I know it's going to take a lot of my time, but I have to explain this properly. The next part for you to determine how does this now help you determine the changes from the graph of p to the graph of, oh no, they don't want the changes. What do they want? They want the minimum value from the graph of the minimum value of the graph of p, right? So for us to get the minimum value there, we are actually looking for the lowest point. So when you're in an exam, and especially when you're well polished with trig functions, you won't need to do this part. But now here, I'll just put it there. A negative cosine is a graph that is an N shape. Right? We don't care about the x values at this point. We only want the minimum value. What is the minimum value of this graph? So the coefficient of the graph of cosine tells you where the graph actually starts, especially if it was not horizontally shifted. So now this graph was not horizontally shifted. There's no value added to x there at all. There's no value added to x. So it was not vertically shifted. So it starts here on the y-intercept. So where does it start? It starts at the -2 part, and the highest point will be at +2. We good? That's what this value, the coefficient of the cos, represents there. It tells you that this graph, its lowest point is going to be -2, and its highest point is going to be +2, if the graph hasn't been moved vertically. We good? So that's what we have here now. So this graph here, its minimum value, its minimum value is how much? It's -2. And this thing, it's 2 marks. Probably they're going to mark this part here and mark this part here. You don't need this part here, the plotting of the graph. But if it needs you to do this for you to get the answer, just do it. Right? So that's what we have for today. I hope all is well. And enjoy maths, guys. I'll throw in the next video as soon as I can. And enjoy. Also, please tell me if you need me to cover the basics actually of trig functions, how to plot the graphs and things like that, so that we go through it. But then if you're fine with that, we can just move on with the topics now, so that I can help you catch up with your work in class. But this is my form of intervention, guys. I hope it works for you. I hope you were able to understand how I answered these questions here. And yes, all the best. Goodbye. Don't forget to like and share. No, just like the video. Thank you.